Okay, so the quest is to do question 13, 16, and 18. I'm just going to do question 13 because 16 is the same method, and 18 we're going to do on Friday in the masterclass. So this question. Now, the work solution uses something called the general term. So if I'm looking at the theory for this, general term for A plus B to the n is equal to nck A to the n minus k, B to the k, okay? And that means the general term for 1 plus x to the 11 is equal to, now that's going to be 11 ck, 1 to the 11 minus k, and then x to the k, okay? Now you could also write the combination notation in this form, 11 ck like this, and 1 to the 11 minus k is just 1, so it's just 11 ck x to the k. Okay, now that's a general term for 1 plus x to the n. Now, also, that general term is called the k plus 1th term, right? Now, the work solution uses that to work it out. I'm not really going to do that. I'm going to just do it a longer way so it makes more sense. Okay, you can see here in your expansion, you've got to prove that this is true. Now the left-hand side is 11c5, so you can see down here that means k must be 5. Okay, so that means your term, if k equals 5, so I put down if k equals 5, that gives me 11c5 x to the 5. So it turns out that 11c5 is the coefficient of the x to the 5 term from this expansion. 1 plus x to the, that should be 11 there, make it a bit clearer, 11. Okay. Now, let's have a look. But now, because the confusion was over the solution, the work solution, I'm going to do a different method, which is a longer method. It's just going to expand it out. So I'm going to look at the left-hand side and the right-hand side. I'll look at the first equation here just as an expansion, okay? So I'm just going to go left-hand side equals 1 plus x to the 11. Now, if I expand that out, that's going to give me 11c0 plus 11c1 that's going to be x to the 1, then plus 11c2 x squared next one is plus 11c3 x to the 3 plus 11c4 x to the 4 plus 11c5 x to the 5, right? That keeps going, doesn't it? It keeps going forever. Not forever, actually. It keeps going up to 11c11 and x to the 11. Yep. Okay, now let's look at the right-hand side. Now the right-hand side is, now let's have a look. 1 plus x cubed. That's sort of 1 plus x to the 8. Okay. Now, if we write that out as an expansion, let's do 1 plus x cubed first. That's going to be 3. So I'll just use square brackets here. 3c0 plus 3c1 x plus 3c2 x squared plus 3c3 x cubed. Okay, now changing colours. That's the 1 plus x cubed part. Now the 1 plus x to the 8 part I'm going to put underneath. All right, so that's going to be multiplied by, now it's going to be 8c0. Let's use square brackets again. So now I'm doing the expansion of this. All right, so it's going to be 8c0 plus 8c1 x plus 8c2 x squared plus 8c3 x cubed plus 8c4 x to the 4 plus 8c5 x to the 5, right? And that keeps going all the way up to 8c8. So I'm just going to go plus dot 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 plus 8c8 x to the 8 close bracket. Okay. Now look back to what you've got to prove. Okay. So all I've done so far is I've written down this left-hand side as an expansion and the right-hand side as an expansion. Now we want 11c5. Now 11c5 is this term here, isn't it? It's one term in the expansion of 1 plus x to the 11. Okay, so what I'm going to do is I'm going to equate the x to the 5 terms. Okay, so I'm going to equate the x to the 5 term here. So that means I'm going to write this down. I'm trying to stick to my colours. So I'm going to take this term here, right? So I'm going to equate x to the 5 terms on the left-hand side and on the right-hand side. Okay, so that means, because obviously if the left-hand side is equal to the right-hand side, that means the x to the 5 term on the left must equal the x to the 5 term on the right-hand side. So if I've got 11c5 x to the 5, right, now that's going to be equal to the x to the 5th term on the, so I'm going to put down x to the 5 here, and then I'm going to put in brackets the terms which make x to the 5. Now how do I make x to the 5? Okay, now let's have a look. I can take this term here, the 3c0, and times it by the 8c5 x to the 5 term, because if this term here, that one there, and that one there are multiplied together, I get x to the 5, don't I? In fact, I'll get 3c0 times 8c5, 3C0 times 8C5, x to the 5. There's my term there. Now, how else can I make x to the 5? I can take an x term and multiply by an x to the 4 term, okay? Which means I'm going to have 3C1 times 8C4 plus 3C1 times 8C4. Now, how else can I make an x to the 5 term? I can take a squared term and times it by a cubed term. So 3C2 times 8C3 will be the coefficient there. 3C2 times 8C3. Okay, so that's the cube term I've used. Now, next, sorry, squared and cubed together. Now, what about this term here, the cubic term? I haven't used this one. Cubic term multiplied by a squared term will give me an x to the 5th term. So that's going to be 3C3, right? And then times by 8C2. Okay, so close bracket. So this x to the 5th term must equal this x to the 5th term, which means the coefficients must be equal. Okay, so the coefficients must be equal. So 11C5 must equal what's in the brackets here, because they're both the coefficient of x to the 5. Now, remember also that 3C0 is 1. Okay, so this here, let me just point here. That 3C0 is 1 and 3C3 is also 1. Okay, so when am I equating my coefficients? So equating coefficients, okay, I'm going to have 11C5 is equal to, and it'll be, now instead of 3C0, that's just 1. So 1 times 8 to the 5, 8C5 is just 8C5. Okay, plus 3C1 times 8C4 plus 3C2 times 8C3 plus, now 3C3 is just 1. 1 times 8C2 is just 8C2. Okay, and that is it. It's been proven.